For all of human history, we have made maps. We have charted the rivers, the mountains, and the great oceans of our world. Each new map pushed back the frontiers of our knowledge and revealed a bigger world than we ever thought possible. Now, our ambition has turned towards the heavens. We are no longer just mapping our planet. We are mapping the entire universe itself. We are drawing the coastlines of ancient galaxies and charting the vast, dark oceans of space that lie between them. This is the ultimate exploration, a journey not across land or sea, but through the immense expanse of cosmic time, all the way back to the dawn of everything. Today, on June 15, 2025, we are living in a golden age of this cosmic cartography. Scientists are using remarkable new tools to create the most detailed maps of the cosmos ever conceived. It is an endeavor driven by one of our deepest questions. Where did all of this come from? The stars, the galaxies, and even us. We are looking out into the darkness to find our own origins, written in the faint, ancient light that has traveled for billions of years to reach us. It's a story that connects every one of us to the grandest stage imaginable, a story that is unfolding right now with each new image and each new discovery. Imagine a map that doesn't just show you where things are, but when they were. That is precisely what these new cosmic surveys provide. Because light takes time to travel, looking far away in space is the same as looking far back in time. The light from the most distant galaxies began its journey when the universe was just a baby, a mere fraction of its current age. By capturing this light, we are acting as cosmic archaeologists, digging through layers of time to uncover the very first structures that ever formed. We are witnessing the universe as it was, seeing the seeds from which our own Milky Way galaxy would one day grow. This grand quest is made possible by a new generation of powerful telescopes, our eyes on the universe. The most famous of these is the James Webb Space Telescope, or JWST. It is an engineering marvel, designed to see the universe in infrared light, which is invisible to our eyes. This special vision allows it to pierce through cosmic dust and capture the faint glow of the most ancient and distant objects. It's like having a time machine that can look back across 13.5 billion years. What it is showing us is rewriting our understanding of the universe, revealing a place that is far more dynamic and surprising than we ever knew. The latest chapter in this incredible story comes from a project called Cosmos Web. Think of it as the deepest, most detailed survey of a patch of sky ever undertaken. Using the unparalleled power of the James Webb Space Telescope, a global team of scientists pointed the telescope at one area of the cosmos and held it there, gathering light for hundreds of hours. Their goal was to build a map that reached further back in time than ever before, to the era known as the Cosmic Dawn, when the very first stars and galaxies were switching on, illuminating the universe for the first time in its history. The result is simply breathtaking. The Cosmos Web map reaches an astonishing 13.5 billion years into the past, covering more than 98% of the entire age of the universe. To put that into perspective, our universe is thought to be about 13.8 billion years old. This means we are witnessing events that happened just 300 to 400 million years after the Big Bang. This isn't just a small glimpse. It's a wide, deep portrait of the infant universe. The map they created is teeming with galaxies, around 800,000 of them in this one patch of sky alone, each one a collection of billions of stars. To truly appreciate this achievement, we can compare it to what came before. Perhaps you remember the famous Hubble Ultra Deep Field image from 2004. That was our best view of the early universe for many years, a remarkable image that showed about 10,000 galaxies. The new Cosmos Web map is vastly larger and deeper. If the Hubble Ultra Deep Field was the size of a standard piece of paper, the Cosmos Web map would be a giant mural, 13 feet by 13 feet. It's a monumental leap forward in our ability to see the cosmos, giving us a much richer and more complete picture of our cosmic history. What this new, deeper view provides is not just more galaxies, but more clarity. With the Hubble telescope, the most distant galaxies were just faint red smudges. We could tell they were there, but not much else. With the James Webb Space Telescope's sharp infrared vision, those smudges are resolving into distinct shapes and structures. We can begin to see spiral arms, clumps of star formation, and even the faint signatures of supermassive black holes at their centers. We are no longer just counting the galaxies. We are starting to understand how they lived, evolved, and grew in the universe's earliest moments. One of the most profound discoveries to emerge from the Cosmos Web Map is just how busy the early universe was. Our previous models, based on data from Hubble, suggested that the first few 100 million years after the Big Bang should have been a relatively quiet time. We expected to see small, infant galaxies slowly beginning to form. Instead, what JWST has found is a cosmic metropolis, bustling with activity. The map reveals about 10 times more galaxies at these extreme distances than scientists had predicted. The universe, it seems, got to work building big things very, very quickly. This finding challenges our fundamental ideas about how galaxies form. The standard theory was that it takes a long time for galaxies to grow. Small clouds of gas and dark matter were thought to merge over billions of years, slowly building up into the grand spiral and elliptical galaxies we see today. But Cosmos Web has found massive galaxies, some with over 1 billion times the mass of our Sun and stars, that were already fully formed when the universe was just 400 million years old. This is a cosmic puzzle. It's like finding a fully grown adult in a nursery, and it forces us to rethink the physics of the early cosmos. This is not a solo mission, however. While JWST provides this incredibly deep pencil beam view into the past, other missions are mapping the sky in different ways. The European Space Agency's Euclid mission, which released its first major data in March of this year, is designed to go wide. Instead of staring at one spot, Euclid is scanning 1/3 of the entire sky. Its goal is to map the distribution of billions of galaxies to understand the mysterious dark universe. It measures how dark matter clumps together and how dark energy is pushing the universe apart, providing the large-scale context for JWST's deep discoveries. And there is another player joining the team soon. NASA's Sphere-X telescope, set to launch later this year, will do something unique. It will scan the entire sky in infrared light, creating a complete cosmic map. While Euclid maps the positions of galaxies and JWST studies them in detail, Sphere-X will measure the light spectrum of every object. This will give us a cosmic inventory, helping us understand the history of star formation across the whole universe, and even searching for the ingredients of life, like water and organic molecules, frozen in interstellar space. Together, these missions create a powerful, multi-layered view of the cosmos. This monumental effort to map our universe is a testament to what humanity can achieve when we work together. The Cosmos Web, Euclid, and Sphere-X missions are not the work of a single person or a single nation. They are vast global collaborations involving thousands of scientists, engineers, and technicians from all around the world. Data from these telescopes is shared openly, allowing anyone with an internet connection to look at the same images that the world's leading astronomers are studying. Science at this scale is a fundamentally human and collaborative endeavor. It is also driven by remarkable technological innovation. The Euclid mission, for example, is facing a flood of data so immense that it would be impossible for scientists to analyze it all by themselves. To solve this, they are pioneering the use of artificial intelligence. An AI called Zubot is helping to classify hundreds of thousands of galaxies, doing in weeks what would have taken humans many years. This synergy between human intellect and machine intelligence is pushing the boundaries of what is possible, accelerating the pace of discovery and allowing us to make sense of the universe's overwhelming complexity. But you don't have to be a professional scientist with an advanced degree to be part of this adventure. The age of citizen science is here. Projects connected to missions like Euclid actively invite volunteers from the public to help with their research. Nearly 10,000 people have already joined in, helping to spot fascinating objects like gravitational lenses, where the gravity of a massive galaxy bends and magnifies the light from a more distant one. You, right now, can contribute to real scientific research, helping to sift through cosmic data and make discoveries from your own home. Exploration is no longer limited to a select few. Ultimately, these maps do more than just chart distant stars. They chart our own place within the cosmos. They tell us the story of where we came from, a story of cosmic evolution stretching back 13.8 billion years. Every atom in your body was forged inside stars that lived and died long ago in galaxies that we are now seeing for the first time. Looking out into the universe is looking back at our own extended family tree. It is an invitation to everyone to look up, to feel a sense of wonder, and to participate in one of the greatest quests we have ever undertaken, to understand our universe and our place within it.